I'm now going to walk you through an empirical formula and then have you solve for the molecular formula. Great test question. So in this situation, analysis of a compound shows it to be 38.71% carbon, 9.68% hydrogen, and 51.61% oxygen. If further data reveals that it has a molecular weight of about 93 grams, determine the empirical and molecular formulas of the compound. So first of all, I must go with my empirical formula. Again, I change my percent to grams. So I have 38.71 grams of carbon, 9.68 grams of hydrogen, and 51.61 grams of oxygen. Then I must get them the moles. I do that by way of molar mass. I get molar mass from the periodic table. Carbon weighs in at 12.01, hydrogen weighs in at 1.01, and oxygen weighs in at 16.00, and all of those are grams per every mole. And I put moles or grams for one reason, so my grams cancel out, but mathematically all I'm doing is dividing by my molar mass. Now I have to set up my mole to mole ratio, and to do that I divide a second time, this time through by my lowest number of moles, which in this situation is 3.22. In the process of doing so, each of these fall close enough within the plus or minus 0.05 range of a whole number. So my empirical formula consists of 1 carbon, 3 hydrogens, and 1 oxygen. I now want to determine the molecular formula. So the molecular formula, if you remember, I have to acquire a multiple that I will distribute through my CH3O and raise it up to its molecular formula. Remember, to acquire that multiple, we take the molecular weight, which is provided for you in the problems, at 93 grams, and I'll divide it by my empirical weight, and that is just the molar mass of my empirical formula. For example, if I weigh out 1 carbon plus 3 hydrogens plus 1 oxygen, it weighs in at 31.04 grams. That's my empirical weight. My molecular weight was the 93 grams provided for me within the problem. So I'll take 93 and divide it by 31.04. Now at this point, we're back to regular rounding rules. And it comes to my nearest whole number of 3. So now I'm going to take my multiple 3 and I'm going to distribute it back through my empirical formula, and I'm going to raise it up to C3H9O3. That is a molecular formula.